Ozmoroid.
Let's take a look at rotational damping in action. Here you have 6 various masses connected by lossy springs. Let's set it to rotating. It begins trying to rotate with the largest mass, the red mass, as the North Pole. As it loses energy, that's unstable, and it begins to tumble. Now it tries to put the green mass at the North Pole. That doesn't work. As energy is lost, it continues to tumble, and now approaches the final state, which will be the state of minimum energy, from which there is nowhere left to go, and that is principal axis rotation with the smallest mass, the blue mass, at the North Pole. And it will continue to just dampen down and eventually go into a state of perfect uniform rotation about this axis. Now, when we talk about an actual asteroid tumbling, what are the timescales for it to dampen down into principal axis rotation? This topic has been extensively studied for decades, and so that you don't think I'm pulling all this out of my nose, let me provide a reference here, Tumbling Asteroids by Pravik et al., and you can also refer to the references in that article that go back at least to the early 1970s. Those authors derive a damping timescale t in millions of years, which is the typical rotation period p in hours cubed divided by 5 times the average diameter d in kilometers squared. Just out of curiosity, let's plug the numbers for Earth into this equation. It's not valid for Earth because Earth isn't a rigid body, it's got a molten core, etc. But 24-hour rotation period, mean diameter of about 12,700 kilometers, and we get a damping time of about 17 years. This tells you why none of the major planets are in non-principal axis rotation. They would dampen so fast, there'd be so much energy being lost from the flexing of the surface that they would dampen down in a very short amount of time. Now, let's look at some actual asteroids. Asteroid Eros, which was visited by the NEAR spacecraft. 5.3-hour rotation period, 17-kilometer mean diameter, and we get 100,000-year damping time. So it should take Eros about 100,000 years to dampen down to principal axis rotation. Asteroid Tuatatis, a mean period of about 130 hours, a mean diameter of 2.7 kilometers, and you get a 60,000 million years or 60 billion year damping time. Now take a guess. Which, if any, of these objects is a principal axis rotator? We know the answer because we've observed these asteroids. Eros is a principal axis rotator. Tuatatis is a non-principal axis rotator. If those were your only 2 points of reference, what would you conclude? Eros has been rotating for more than 100,000 years. Tuatatis has not been rotating for 60 billion years. Now let's consider asteroid Itokawa, a little teeny guy at only about 600 meters across. It has a rotation period of about 12 hours and a mean diameter of about 0.61 kilometers. Punch those numbers and you get 929 million years, almost a billion years. Now take a guess. Do you think Itokawa is a principal axis rotator, implying that it's had more than about a billion years for its spin state to dampen? Well, yes it is. It is a principal axis rotator.
Is that the point?
Well, yes, now this is kind of the point. To date, more than 1,000 asteroids with spin damping times much longer than 6,000 years have been observed to be in uniform principal axis rotation. Now you might argue that a couple of those just happened by chance. You just happened to smack the football with a baseball bat and it went into a perfect spiral. But not in 1,000 out of 1,000 cases. The conclusion is that these asteroids have been rotating undisturbed for much longer than 6,000 years, therefore allowing sufficient time for rotational damping. If you claim that the solar system is only about 6,000 years old, then you are taking ownership of the following falsifiable prediction. Asteroids with spin damping times greater than 6,000 years should not have settled into uniform or principal axis spin states. To date, this, quote, prediction has failed more than 1,000 times. The fact is the solar system is much older than 6,000 years. In fact, it's much older than a billion years. We know. We have evidence. Simple Newtonian mechanics proves that the solar system has been around for orders of magnitude longer than 6,000 years. To deny this is to deny the basic laws of mechanics, And this is why, quote, creation science is most definitely not science. It doesn't even agree with F equals ma, basic Newtonian physics, for goodness sake. And this is why any scientifically minded person will tell you that the biblical creation story, or any of its derivatives, has no place in a science classroom. Freedom of religion, yes. Pollution of science education, no.
I guess that's a pretty good point.
Well, thank you. Let's finish off by watching this three-dimensional model of asteroid 4179 Tutatis tumble off into the sunset.